Good morning, good morning. It is Thursday, April 16th. That sounds right. Yeah, here we are, guys. I'm filming on Wednesday morning. That's why I never understand what day it is. Start the day with a little atmosphere. It's called Yesterday. It makes me think of you guys. I don't know why. It's good to see you. Let's do this. All right, guys. We've done a little bit of research. You guys did some work that you turned in last night for you guys, Wednesday, April 15th. You turned in part 1 of the muscle rules assignment, where we learned our overall breakdown of skeletal, smooth muscle, and cardiac muscle. You'll often see skeletal muscle referred to as striated muscle. I may talk about that a little bit later on here. You guys have filled out a table here, and sorry I didn't clarify this. The histology part, I'm actually not going to ask you guys to worry about. I covered a little of the histology by looking at these cells down below and seeing what we could tell similarity and difference-wise between skeletal, smooth, and cardiac muscle. What we should see with skeletal muscle, and it maybe doesn't come through as super clear as it should here, but we have parallel bands that we see. So if we zoom out from one muscle cell and we see muscle fiber, we'll see a lot of these parallel bands, and that gives like a striated look to a skeletal muscle. A smooth muscle doesn't have those striations, so it's not as clearly defined in terms of those different parallel bands that we think of when we think of skeletal muscle. And cardiac muscle is also a striated muscle, but we don't have the parallel bands. We don't have long lines that we'll see. We'll see a band here, we'll see another band over here, another one down here, where they're kind of just mixed throughout. And so we don't see the super detailed or uniformity of the striations of a skeletal muscle. But those are striations also. So you may hear cardiac muscle called a striated muscle, but those spaces there are called intercalated discs. So I would want you to know that an intercalated disc is something that we would associate with a cardiac muscle. You answered a few questions about differences that we may see in those types of muscle tissues. And finally, a question down below about the structural makeup of a muscle, how that contributes to its ability to do its job. So what we are starting to do here is we're starting to connect what these different types of muscles do for different jobs in our body. And I'll cover that in our PowerPoint here in a few. For today's assignment, for Thursday, April 16th, what I'm assigning today is not due until Monday night, April 20th at 10 p.m. And as most of you, hopefully all of you are aware, the Board of Education voted last Friday for us to work through our spring break, which would have been next week, the week of April 20th through the 24th. So we actually don't have an official spring break. We're going to work through that so that we can get out on May 22nd. So that's exciting. But I also know that I've been staring at this computer every day, it feels, for extended hours for the last 4.5 weeks. My eyes, my brain, and probably my soul needs a little bit of a break from staring at this computer. So what I'm looking to do is not give you a folder, an assignment folder next Tuesday, the 21st. The only folder you'll get from me will be next Thursday, the 23rd. Just to probably wrap up some things in regards to joints and muscles. And that will be it. So it'll just be a 1 day of post next week so that we don't just completely forget about school for a week. I do think staying in this routine of whatever you're doing to make it work for you, which you guys are doing great. I get excited every time I open your assignment folder. So I'm like, cool, you guys are on it. And when you guys aren't, for whatever things occur in your world, whether it is just wonderful CenturyLink Wi-Fi that's just not working for you that day, or if it's Schoology issues, or if it's other stuff that's going on, I really just appreciate from you guys just communication, just letting me know before the fact, maybe before the due time or day, saying, hey, Dupree, I'm having all kinds of issues and I cannot get this done. Can I get this to you tomorrow? That's not an issue, guys. And I'm not really going to get hung up on those details because you guys are staying on top of things. If you guys continue to produce what you've produced the last 4.5 weeks, we're going to finish out this year just fine. Okay, so let's hop into this PowerPoint that's really going to walk us through a lot of what you've worked on already, and hopefully maybe clarify a thing or two. So let's bring this up. Muscle rules. What we're going to get to is you're like, I don't know what that means. Great. Muscle rules do pretty cool. There's actually some rules that you're going to research, rules in regards to muscle function. That'll be kind of the last question or in the last group of questions that I ask you for this assignment. More words than I would prefer here. Let's see if I can go to present mode. I swiped this from a colleague of mine, and I wish I could have taken a little more time to maybe cut down on the level of reading here, but maybe I'll read to you guys. You haven't heard me read in a while. All movement in the human body, from wiggling a toe or swimming a mile to eating and digesting a sandwich, is the result of muscle action. In previous lessons, you've learned about connective and nervous tissue. In this unit, you guys are exploring the structure and function of the muscle, and another incredible tissue. So muscle tissue is another type of tissue. When we think of muscles, we usually focus on the muscles that move our bones and allow us to move about the earth or to just sit on the couch and barely stay awake as we continue to watch Netflix. The tissues we see from the outside, that's what we think of, these muscles. When I always say, go ahead and just contract a muscle right now, and you'll contract your bicep or something like that. But inside the amazing human that we are, you will find other types of muscle tissue that work silently to move substances around the body. Your heart keeps beating. We don't control that. And food continues to digest even when you fall fast asleep and close your conscious mind for the day. Food continues to push down our esophagus, through our stomach, and through our small intestines. Without muscle moving blood or distributing nutrients from food, the human machine would effectively shut down. There's 206 bones in the human body, but over 600 skeletal muscles allowing our bodies to move in all the different directions that we move. More than 60 of these muscles are found in your face alone. Have fun making faces. I used to have ugly face contests with this girl in college whenever I'd see her out around town. We'd have an ugly face contest. I won it every single time. As we see, you use 40 of these muscles every time you frown, but only 20 muscles when you smile. So those that are just wanting to frown more, you could say, hey man, I'm just working out my body more. The human body is even built to make it easier to be happy than to be sad. Skeletal muscles are attached to bones with tough cords or sheets called tendons. So when we're connecting muscles to bones, those are tendons. And these bones meet other bones at junctions called joints. The contraction or shortening of muscles pulls on bone and moves the body. In this activity, you will observe and compare the structure and function of the three types of muscle tissue. You'll explore the structure of skeletal muscle both by looking at slides and by creating a model of a muscle unit. We're actually not going to do that last part. We're not really in our lab to be doing those types of things, so we won't create a model for this. So what we have here, I'm not going to play this Khan Academy video, but it's a great supplement to go over, why don't I scoot me out of the way, the three types of muscle. And so what we want to make sure we know are skeletal muscles, smooth muscles, and cardiac muscles. Describe what it means if a muscle is striated. Those cells are aligned in those parallel bundles so that their different regions form visible stripes. So when we say striated, think striped. What does it mean if a muscle is said to be under voluntary control? Well, that's simply enough. We can control that. We can tell certain muscles of our body when to contract and when to relax. We have other muscles that are involuntary, meaning we really, from our brain, from our nervous system, we don't have a control. I can't sit here right now, and neither can you. We can't sit here and say, okay, I want my stomach to contract right now to start digesting that food. It's actually already doing it. Finally, describe the difference you see in the three types. As I talked about before, skeletal muscle has those parallel striations. Smooth muscle is just not striated. You don't see clear delineations of those stripes. And then cardiac muscle is striated, but at irregular points. So we don't see those real parallel stripes. Instead, we just see different areas where those striations are. And we call those areas intercalated discs. Your muscle histology table that you filled out, here's kind of a breakdown of those answers. Knowing which muscles are striated, knowing which ones are voluntary, those are absolutely essential. And then knowing where they're located. We know that muscles that attach to our skeleton, those ones that we can voluntarily control, those are our skeletal muscles. It makes sense. And that allows us to move our skeleton in all the ways that we want to move our body. Smooth muscle, those are those involuntary muscles that basically line the walls of hollow visceral organs that are trying to move things through. And we think digestive system, think your esophagus, think your stomach, and think about your small intestine. And that process of moving food through our digestive system, it isn't just like a gravity thing. There's actual muscle contraction. Some of you may remember that term that we learned for that involuntary contraction of the smooth muscle of our digestive system. Going once, going twice. Peristalsis. Peristalsis is that contraction of the muscle. And I put in here, it's like housekeeping. It's moving food through our digestive system. Finally, cardiac muscle. That should be one we connect back to all that we've learned about the heart. That's the actual muscle cells of our heart. That is all cardiac muscle. Another video here to look at, to watch in regard to anatomy of a muscle cell. I've also posted this document, and you can open it and you can actually move these off if you want to move them back on and just do your own practice of matching. And what we want to see here is, as we look at a muscle, a whole muscle grouping of fibers together is all, like when we say one muscle, like the muscle of biceps brachii, which is your bicep on your arm. When we talk about that muscle, it's a whole bunch of fibers that are all kind of lumped together in all these little, we almost like circular groups. So we call those each, we break that down. Let's start from the outside. The entire muscle itself is surrounded by a connective tissue called epimysium. And then as we go work our way inwards, we can see that there's a grouping of muscle fibers. That grouping of muscle fibers, that circle that we see there, that is surrounded by some connective tissue called perimysium. And then if we zoom in even further to one specific muscle fiber that they've actually kind of pulled out or teased out for us there, that one muscle fiber, now we're getting down to the cellular level. And that's going to be surrounded by connective tissue called endomysium. So we've gone from the outer covering, which is the epimysium, to the covering of one of the grouping of fibers called the perimysium. And finally, what's wrapped around the one set of muscle cells or muscle fiber is called the endomysium, or the internal covering for the muscle fiber. A grouping of all those fibers, where again, it's been surrounded here by perimysium, that's called a fascicle. And so that's that term that we see down here. This entire grouping of those fibers, that's a fascicle. Otherwise, where we see at the end of the muscle cells is actually that connective tissue that connects muscle to bone, and that's called a tendon. Okay, so where you see that whitish area, that's the tendon. So when we contract a muscle, it's actually telling, a part of our skeleton to move. Okay. So again, I'm going to move myself around. Now that we've learned about muscle structure, let's start to think about its function. We know that muscles help our skeletal system to move, but how are these tissues oriented on our body? What are the rules that muscles live by? Note that the name of a muscle gives you clues about the makeup of that muscle. So a lot of the names, there's tons of overwhelming Latinness to the names of muscles, but you guys have already learned a ton about the bones of the body and the regional terms of the body and directional terms. Those three things right there actually very often are going to help you to get a feel before you even just go run and Google or yell at Siri to answer something for you. You can actually say, oh yeah, that's probably something that's found in this part of the body because I know that bone is found in that part of the body, or that is the regional term for that part of the body. So this is just for you to play around with. These terms are names of muscles. And by reading them, again, a lot of Latin basis, so you're like trapezius and rhomboid. when we see something like that, you may actually think, oh, yeah, I've learned about a rhombus, maybe in math or geometry more specifically, or a trapezoid. Yeah, that's actually where the basic root of these terms comes from, is it comes from the shape of the muscle. So that doesn't actually tell you where it's found necessarily, but that may help you to understand the actual shape of the muscle. And I'll scoot over that one, which that one's referred to often when you hear people mention gluteus maximus or gluteus minimus. But as we get on to frontalis and temporalis, where have we learned those terms? Oh yeah, think back to the bones that we learned back in first semester. And if you've already yelled it out because you're like, dude, I got this, you're thinking about parts of the brain. In the bones of the skull around the brain, when we think about the frontal bone and the temporal bone, or the temporal lobe and the frontal lobe of our brain, yeah, that's where we're thinking about the muscles that control these areas of our skull. So if I'm controlling temporalis, I'm maybe even moving my ears a little bit. So again, you can go through these, and it's up to you if you want to type answers in. That's just for your play to think. Before I just Google these things, can I actually use knowledge that's actually packed in my brain somewhere to start to think about where these bones might be, these muscles might be found in our body? So this will actually take you through a little bit more detail of the naming of the muscles. I do want you to watch it. This is when you have a few minutes. It's not a must. I'm not going to ask every detail, but it's going to help you a lot more in knowing how to name the muscles. I'm probably going to circle around back to this a little bit next Thursday as we wrap up a little bit of muscles. And I think we actually have this question in our assignment. So I'll have you think about it, but this is actually going to show up in your Part 2 assignment, where your mom comes back from the doctor and says she's pulled her tibialis anterior. I'm going to ask you guys to not run to Google, not run to Siri, not run to Alexa or your medical professional parent. I want you to just take what you know about the terms, how you can break down tibialis and anterior, and think about where that muscle might be and how that might affect your mom. Okay? And so that's a quick overview of some things that I think may help a little bit as you jump into Part 2 of 4.2.1, which is muscle rules. And again, we'll wrap up some of this bigger look of things next Thursday, bigger look of muscles. And then I'm going to zoom in to muscle cells, and we'll talk a little bit about how a muscle actually contracts and how this electrical working of our body, the electrical signal that comes from a nerve, for instance, to tell a muscle to contract, what is actually happening at the molecular and cellular level. It's absolutely crazy, but it's also kind of tricky. So I do want to put a lecture together for you guys for that. Otherwise, guys, like I said, I'm not going to post a folder next Tuesday, April 21st. I'm sure I'll probably just send a message out to say, hey, and hope that you guys are taking care of yourselves. And that if you do have questions, or if you're working on getting caught up on anything, that I'll be still around. I will be available completely to answer any questions that you guys have. That being said, guys, dig into Power School. If there's anything since we've gone online, April 16, if there's anything that's missing for you, anything that's a zero, get after it and do it. There's a fair chance if you turn it in and message me and say, hey, Dupree, I got caught up, I finished that one assignment, there's a pretty darn good chance I'm going to grade it and give you points for that. So please take advantage of that next week. I'm not looking to give you much other than just next Thursday's assignment post. Guys, I hope you're well. I miss you. And let's get out of here with a little more atmosphere. Stress and setbacks, yes. You can tell me how hard you had it. And you can show me all the scars to back it. You know, my guy says hi. He misses you too. He knows you guys talk about him. He's got ears that are big and hear everything. So Howie says, hey. All right, let's get out of here. Later, guys.